Hello, this is Paul from Tech. In this video, let's prove Theorem 4.7.2, transition to standard basis in n-space Euclidean space. It says if B is any basis in n-space and S is the standard basis, and C, the transition matrix from B to standard matrix is just put the vector in the basis together to form a matrix. If U1, U2 are the column vectors, see the first column, the second column, and the last column, we simply say this is a matrix. Okay, so how to prove this? I introduced two methods. The first is by definition, the second by algorithm. Okay, so by definition, so what is the transition matrix we defined? Okay, column by column. Okay, put all the coordinate vectors, right? See, let me write. Okay, that's the definition. Each column is the coordinate vector of a ui under the standard basis. And we learned before, okay, any vector, the coordinate vector the coordinate vector of any vector under standard basis just equal itself, okay, which is this y. So let me give examples, like we pick u1. For example, u1. Let me set up u1 is this is x1, x2. That's the coordinate, and we easily to break down this Euclidean vector into a linear combination of the bases, right? So after we break it down, we should be this linear combination, right? See, this is a linear combination of the standard basis. The coefficient should be what? The coefficient, so that's the coordinate vector of u1 under the basis. See, it is. And then of course this is itself, right? So just u1 itself. So therefore, what do we get? And each column is just the vector ui itself. So we put them together. So we find the transition matrix. Okay, and this is a B, right? Okay. In column put it together. That's the proof by definition. And then I introduce another method by algorithm, even simpler than this one. What is the algorithm that we use to find the transition? Here is the algorithm. Okay, so this is the algorithm that we learned. Specifically in Euclidean space, we can do this row operation. If we need to find a transition from B to B prime, we put a B to the right and then put a B prime to the left. So B is just put all the vector in the basis B. The column vector together form a matrix. See, this is a matrix, this is a matrix. And therefore we do row operation. If the first B prime, what do we find? The reduced row echelon go to identity, and then B will change to the transition matrix. That's the algorithm, right? Algorithm we need. Now what do we need to find? We need to find B to S. So I change the B prime to S, standard basis. Okay, and then what do we have? Here should be the transition from B to S, right? Okay, so this we follow the algorithm. But now we just simply check what is S. Okay, S is just identity. If we put E1, E2, En together, it's just identity matrix. See, it's already identity matrix. Therefore, we don't need to do any row operation. We don't need it's already. So therefore, these matrices should be the matrix B itself because it keep the same. So directly we have the result. Right? That's the proof. Thank you.